All right, so PDS number 3, we're graphing the function f of x equals x plus 1 cubed times x minus 3. And this one I factored for you because it would be too big for you to factor on your own. All right, so we start off again finding x-intercepts. We set this guy equal to 0, and it's already factored, so all I have to do is set those factors equal to 0. The first factor I set equal to 0, I get x equals -1. The second one gives me x equals 3. Of course, -1, the factor, is cubed, so I know that the multiplicity for -1 is 3. Wow, that doesn't even look like it's in English. Let's try that again. Multiplicity is 3. Okay. So then the multiplicity for 3 is 1 because its exponent on its factor was 1. So it's just going to behave like a regular x-intercept at that point. So I'm going to come over here and give myself x-intercepts at -1 and at 3. And then I'm going to remind myself that at -1, this needs to behave like x cubed, like a cubic. And it might be like x cubed or like -x cubed. It's just going to flatten out there like x cubed does at the origin. All right, so that's our first one. Our next step is to find the y-intercept. And for the past 2 problems, finding the y-intercept has been sort of boring. All right, but this one will actually get something. When I find f of 0, I'm going to plug in 0 for x. And then that leaves me with 1 cubed and -3. So I get -3. So this has a y-intercept at -3. All right, so I have my y-axis kind of zoomed out a little bit here. So -3 is right there on my y-axis. All right, next thing is end behavior. Okay, so end behavior was easy on the last 2 because they were all FOILed out for us, but this one is already factored. So you need to think about, if I write this out, if I were to FOIL this, which I am not going to do, I think that would give us all nosebleeds. All right, so if I were to factor that out, I think I would get, for this here, if I FOILed that out, I would get x squared plus some other stuff. Okay, and then I would multiply that x squared business times another one. And x squared times another x would give me x cubed times, or plus a bunch of other stuff. And then I would multiply that times x minus 3, which would give me x to the 4th, plus or minus a bunch of other stuff. Okay, but we're only really interested in that leading term that tells me that this is a degree 4 polynomial, and that the leading coefficient is going to be positive. Okay, we don't even care positive what, but look at those x's. None of them have a negative sign on it that's going to make that x to the 4th term go negative. So this is an even degreed polynomial with a positive leading coefficient. So this is going to behave just like positive x squared. It's going to start high and it's going to end high, because x squared is a even degreed polynomial with a positive leading coefficient. Okay, so I'm going to put my reminder arrows that I need to start high and I need to end high. All right, next stop is to plot a few points. And again, you don't have to plot as many as I do. You need to have at least 2 just to get a good idea of what your graph looks like. And the numbers that are next door to your x-intercepts would be f of -2, that's to the left. F of 1, we could do f of 2, and you could do f of 4. I think I just realized that this function was named h. Okay, I'm going to stick with f, since I've written that too many times. Okay, so f of -2, we're going to plug in -2 for x. Okay, so that gives me -1 cubed times -5. So that's -1 times -5, which is 5. Oops. Attacked by a kitten in the middle of a graph. All right, so I'm going to plot the point -2, 5. All right, and again, you can keep doing that with all of these points. You can plug in x equals 1, x equals 2, x equals 4. All right, for x equals 1, you're going to get -16. F of 2, you're going to get -27. And f of 4, you're going to get 125. All right, so I'm not going to plot that last point. That seems a little ridiculous. So I'm just going to skip that one. All right, but I am going to plot f of 1 is -16. F of 1 is -16. And f of 2 is -27. All right. Okay, and then we have everything that we need. We know we need to start up high on the left. We need to go down through that point at -2, 5. Make sure we flatten out at -1 like x cubed. Okay, so I'm going to start as high as I can here. And I'm going to come down and I'm going to flatten out at -1 just like x cubed does. Oops. See if I can connect that better. And then I'm going to head down through these 2 points that I plotted. And then end up high. All right, and that's it. Just kind of looks like a parabola that somebody pooched their finger on and made a little dent there at x equals -1 because of that multiplicity. All right, I will see you for the next one.